Dear students, I am going to continue from question number 41. Which of the following is not unit of pressure? We know unit of pressure is nothing but pressure units are pascals, Newton per meter square, or torr, or bars, or atmospheres. These are the units of newtons. So here torr is the unit, bar is the unit, and also we have meters of Hg or centimeters of Hg or mm of Hg. These are the units of pressure. So this is also unit of pressure. This is not the unit of pressure. Answer is C. Find the correct statement of the following. We know viscosity decreases with temperature in liquids and increases with temperature in gases. This is direct statement we have discussed already. Next, 43 question. The coefficient of viscosity has the same dimensions as that of energy into time. No. Force into time. No. Pressure into time is the correct answer, because coefficient of viscosity is equal to shear stress divided by shearing strain. So here shearing shear stress is equal to force per unit area divided by shearing strain is nothing but shearing strain rate, not strain rate. Shear strain is delta L by L and strain is delta L by L into delta T. This is shear strain. So right, force per unit area is nothing but the units are pascals divided by units of delta L are nothing but meters divided by units of L are meters and units of time period is S. So here this and this get cancelled. When this S 1 by S comes to S, so eta is equal to pascals into seconds. That is nothing but pascals are the units of pressure into time, pressure into units of coefficient equal to pressure into time units. That is Pascal second is called 1 poise. Next, question number 44. A plate of 30 by 20 centimeter square, area is equal to 30 by 20 centimeter square. Convert it into SI system of units, that is 10 power minus 4 meter square, and with a velocity of 2 meter per second, and area is given, velocity is given, on a table on which a liquid of coefficient of viscosity eta is equal to 0.1 pies, 0.1 pies, and now so that the liquid film has a thickness of L is equal to 0.05 millimeters, that is 0.05 10 to the power of minus 3 meters. Okay, we have this. The force required to drag the plate is, we know that coefficient of viscosity is equal to F into L by A into V. Okay, see here, why A into V? Because delta L by delta T is nothing but V. So coefficient of viscosity is equal to F by A divided by delta L by delta T is nothing but V by L. So when it comes to numerator, it will become L by V. So coefficient of viscosity equal to F by A into L by V. So F into L by A into V. I have written the same. So now the amount of force required to drag the plate is, now the amount of force required equal to eta A V divided by L. So eta value is known, 0.1. Area is also known, this one. V is also known, 2 meters per second, and L is also known, this one is the L value. Substitute in the formula, you will get the answer for this question. It is 240 newtons. Okay, the excess pressure in a soap bubble is P, bubble of radius R, volume is V, volume of the bubble is V, and the surface area is A, surface tension is T. The excess pressure in the bubble is proportional to, the excess pressure in the soap bubble is proportional to 4S by R. That means excess pressure is directly proportional to 1 by R. Okay, So here he has given R. This is not the correct answer. So 1 by area. This is also not the correct answer. 1 by T. It is also not the correct answer because excess pressure is proportional to surface tension S or T. These three are wrong answers. Correct answer is C. We will see how it is correct answer because the volume of the sphere is equal to 4 by 3 pi r cube, and that means volume is directly proportional to r cube and volume power 1 by 3. I am dividing powers of both sides with 1 by 3. So r cube to the power of 1 by 3. This and this get cancelled. Therefore, v power 1 by 3 is directly proportional to r. That means r is proportional to v power 1 by 3. We can replace r with v power 1 by 3. So here excess pressure delta P is proportional to 1 by r. R place low, substitute v power 1 by 3 here. So that delta P is directly proportional to v to the power of minus 1 by 3. This is the answer. Answer C is correct. Okay, now a ring of inner and outer radii. A ring is there like this. Inner is there and outer is there. Inner radius equal to 7 centimeters and outer radius is 9 centimeters. For this ring, this surface tries to decrease the area of the surface. Here also this surface is there. This exerts force like this. Okay, so this force per unit length is nothing but surface tension. Okay, there are two surfaces. We know surface tension is nothing but S equal to force per unit length. So force is equal to surface tension into length. Here length is nothing but circumference of the circle. Circumference of the inner circle plus circumference of the outer circle. So F is equal to surface tension into circumference of the inner circle is 2 pi r1 plus circumference of the outer circle is 2 pi r2. So the correct answer is force S equal to S into 2 pi into r1 plus r2. Has given surface tension equal to 70. Here S is equal to 70 dynes per centimeter, that is nothing but 70. 1 dyne is nothing but 10 to the power of minus 5 newtons divided by 1 centimeter is nothing but 10 power minus 2 meters. So S value is known, 2 is known, pi is known. R1 is 7 centimeters, which is equal to 0.07 meters. 9 centimeters is R2, that is 0.09 meters. Substitute all the values, S value, R1 value, R2 value, in order to get the equation value for force. Okay, right. I am getting different answer for this force that is not available in the options given. No option is correct. You will get the different answer for force in this case. Now, when capillary tube is made up of glass, is dipped into the water, the liquid rises up in the tube due to adhesion forces are more than cohesion force between glass and water. In case of glass and water, adhesive forces are more than cohesive force. That's why the shape will be like this. We have discussed already in surface tension. The answer is C. And this is a direct question. In the case of 48th problem, I have not mentioned surface tension of soap here. Surface tension of soap, that is 3 into 10 to the power of minus 2 Newton per meter. Okay, so this should have been given. So that is missed in this question here. Now a soap bubble of radius r is equal to 5 millimeters, 5 into 10 power minus 3 meters, is closed in a closed vessel, contains air under a pressure is equal to how much? 20 pascals. The pressure of the air inside the bubble. What is the pressure of the air inside the bubble? Okay, we know P minus P naught is equal to, this is soap bubble. As this is soap bubble, we should use 4S by R. So P minus P naught, P minus P naught is 20 pascals is equal to 4 into, sorry, S is nothing but surface tension, that is 3 into 10 to the power of minus 2 divided by R is 5 into 10 power minus 3. By solving this, you will get the answer for P equal to 44 pascals. So this is the answer. Now, a water in a river 20 meters deep is flowing at a speed of 10 meter per second. Velocity equal to 10 meter per second, and here L is equal to 20 meters, and shearing stress between the horizontal layers of the water in the river is how much? Shearing stress is how much? And he has also given coefficient of viscosity, that is 10 to the power of minus 2 SI system of units. Okay, that is pies. Right. Okay. So coefficient of viscosity equal to shearing stress divided by strain rate, that is V by L. We know strain rate is nothing but delta L by L is strain. Okay, I am giving again, a strain is equal to delta L by L, and strain rate is equal to delta L by L into delta T. Strain rate delta L by L by delta T. So delta L by delta T is nothing but V by L. That's why I have written strain rate directly as V by L. So shearing stress is equal to eta into V by L. Eta value is given, V value is given, okay, 10 meter per second. L value is also given, 20 meters. So you will get shearing stress using this formula, right? Wetting agent will decrease the contact angle. Direct question we have discussed already in the classroom. Find the depression of the meniscus in the capillary tube of diameter D is equal to 0.4 mm. So radius R is equal to 0.2 mm. That is 0.2 into 10 power minus 3 meters. Now is asked to find out depression H. What is H? And is also given density of mercury. Density of mercury equal to 13.6 into 10 to the power of 3 kg per meter cube, and surface tension S is equal to 0.4 Newton per meter, and contact angle theta is equal to 135 degrees. Okay, now the depression formula or height rise formula is equal to 2s cos theta by rho r g. So 2 into s is 0.4 into cos theta, cos 135 divided by rho. Rho value is nothing but 13,600 into r is equal to 0.2 into 10 power of minus 3 into g value is 9.8. By solving this, you will get the answer nearly 0.02 something. So this is the answer. Okay, define density, pressure, Pascal's law, and obtain an expression for the variation of pressure with depth. These are the descriptive questions. You can solve again by seeing the notebook or textbook. Okay, now state Bernoulli's principle. What is Bernoulli's principle? For an ideal flow, ideal fluid is nothing but which is incompressible, non-viscous, irrotational, and isotropic. So for an ideal fluid, the sum of the pressure and the kinetic energy per unit volume, potential energy per unit volume remains constant. And obtain an expression for the Bernoulli's principle, that is P plus half rho V square plus rho GH equal to constant. Prove this relation. We have discussed already in the classroom. Right. Derive an expression for speed of efflux. Torricelli's theorem. Okay, speed of efflux means speed of outflow. We have discussed already in the classroom. What is venturimeter? Derive an expression for flow speed of incompressible fluid. Next, define viscosity. and obtain an expression for terminal velocity of raindrop. Right. Define surface tension and obtain an expression for pressure difference for water drop. Okay, what is capillarity and derive an expression for capillarity rise. That is capillary rise H equal to 2s cos theta by rho rg. Derive this expression. Okay, with this question bank explanation comes to an end. Thank you.